Hi everyone, today we will discuss problems in vectors. So if you see the first example, so we have vector p plus q, vector p plus vector q is equal to vector r, and mod of vector p, mod of vector q and mod of vector r, they are same, and p mod of p is equal to mod of q is equal to mod of r. Then what is the angle between vectors p and q? So we have to find the angle between the vectors p as well as q. So from this vector addition, see, let us say angle between P and Q, it is alpha. So from this vector addition, from this equation, we can write R is the resultant of the vector, that is P plus Q is equal to R, means R is the resultant of the vectors P and Q, and angle between the vectors P and Q we have assumed alpha. So considering this, we can write R square is equal to P square plus Q square plus twice of PQ cos alpha. Here magnitude of all these three vectors are same. So here when we say R square, P square, these are the magnitudes of the vectors P, Q as well as this R. So this you can replace this R square by P square because they are same in magnitude. Similarly, I can replace this Q square by P square so that left side and right side all parameters are same. So this becomes your p square is equal to p square plus twice of p square, and q is replaced by p, so twice of p square cos alpha. So that you can see here. So simplifying that, because p square is equal to 2p square plus 2p square cos alpha, 2p square if you bring this side it will be equal to minus p square, minus 2p square means minus p square will get eliminated, minus 1 divided by 2, so that becomes minus half. So from there we can calculate cos alpha is equal to minus half. When cos alpha is minus half, we know alpha is equal to 120 degrees. So we can get this value, alpha is equal to 120, any angle between both. So here in this question, we have vector p plus vector q is equal to vector r. Vector p plus vector q, it is equal to this vector r, and magnitude, yani mod of p plus mod of q, that is sum of p plus q, or the magnitude of p plus q, it is equal to magnitude of this vector r. Then we have to again find the angle between the vectors p as well as q. So again if we take angle between the vectors p and q, it is alpha. Then again from vector addition you can write r square is equal to p square plus q square plus twice of pq cos alpha. Now this is algebraic addition, or you can say scalar addition. Just we have the sum of, yani mod of p plus mod of q. So here we are not considering the this p and q as a vector, we are just considering the magnitude of vector p as well as magnitude of vector q. So this becomes, you can say, an algebraic addition or simply a scalar addition. So from here, if you square both the sides, so we will get r square is equal to p plus q whole square. You can write mod of p plus mod of q whole square, that is same as p and q, because if you have this vector p and if you want to simply write the magnitude of this, so you can write mod of p either this way or simply this, because we have replaced or we have removed this vector notation from here, so that part simply represents the magnitude of that particular vector. So this way we can write. So r square is equal to p plus q whole square, that is p square plus q square plus 2pq. Now see here in this equation 1, we have this as r square, in equation 2 also r square. So left side it is same, so right side it has to be same. So p square q square, here it is same, twice of pq, that is also there. Cos alpha is absent here, but the coefficient of 2pq here it is cos alpha, and coefficient of twice of pq here it is 1, 2pq into 1 you can say. It means cos alpha is equal to how much? This 1. And when cos alpha is equal to 1, means alpha is equal to 0 degree. So from there we can get alpha is equal to 0 degree. So this gives you the angle between the vectors p as well as q. So here in this question, if you consider this question, in this the mod of p plus q, that is mod of vector p plus vector q, is equal to mod of vector p minus q. Again we have to find the angle between these two vectors, that is p as well as this q. So here if you assume angle between the vectors again p and q as alpha, So from this equation, mod of p plus q. So if you consider squaring both the side, so can you again write p square plus q square plus twice of pq cos alpha is equal to p square plus q square minus twice of pq cos alpha. Here it is p plus q, so obviously it will be plus sign here if you consider this, and here it is minus sign, so you will get this minus sign here. So p square plus q square minus twice of pq cos alpha this side. Now simplifying this, so this p square plus q square, p square plus q square gets cancelled. If you bring this minus 2pq cos alpha to the left side, then that becomes 4pq cos alpha, and that is equal to 0. 4pq cannot be 0 because p and q are vectors and they are not 0 vector, they are having some magnitude. So this cannot be 0, it means cos alpha has to be 0, and when cos alpha is 0, this implies what? Alpha is equal to 90 degree, because cos 90 is 0. So from there you can calculate this alpha is equal to 90, and angle between means angle between vectors p and q, it is 90 degree. So see now this example, here in this two forces and they are equal in magnitude, they are acting as shown in this diagram. Okay. We have to find the resultant of these two vectors. So it means if you consider O as a particle, O is a particle or there is a particle at point O, either way we can narrate this. So there is a force 100 Newton acting at this point O or acting at a particle located at this point O. Similarly 100 Newton in this direction. So 100 Newton this side, 100 Newton this side. We have to at an angle of 60 degree. So we have to find the resultant of these two vectors. Just to get this resultant of these two vectors, so if you consider, so component of this vector, let us first find the component of this vector, because this is already acting along x-axis. If you consider this as an x-axis, so this vector is already along x-axis but towards negative of x-axis. You can see this is the direction of this arrow, it means it is acting this side. It is, if you consider with respect to this line, and this is the point O or the particle at point O, so this force is trying to pull it this side and this force is trying to pull it this side, because here this is the direction of this applied force. So this force is pulling it this side and this force is pulling it this side. We have to find the resultant. So whenever you have any number of forces, the best way is calculate the component of all the forces along x-axis and y-axis. X will be added or subtracted with the x components and y will be added or subtracted with the y component. All forces along x-axis, all forces along y-axis. Then depending on the direction, either add them or subtract them. So, and after that we will find the resultant. So if F is the resultant force, so can you say F, it will be equal to Fx square plus this Fy square root. F is the resultant force. Fx means sum of all forces acting along x-axis. Fy means sum of all forces acting along y-axis. If we can calculate these two, then both these forces will be acting at what? Right angle to each other, and once they are at right angle, the resultant is always Fx square plus Fy square root. So that way we can calculate angle between that resultant and x-axis. If it is suppose alpha, then from here you can calculate tan alpha is equal to y component divided by x component, means Fy upon this Fx. So here let us say this is your Fx, okay, and sum of all forces along x-axis, and this is your Fy. This is the resultant F. Makes angle suppose alpha with the x-axis. Then this gives us what will be this angle that it makes with the x-axis. Okay, so that way we can calculate tan alpha is equal to Fy upon this Fx. This is one of the method, and this is the best method, because if there are many number of forces, similarly force, it is a vector quantity, so it is not applicable only for the force, it is applicable for any vector, whether it is a case of displacement, whether it is moment, whether it is any other vector quantity, if you consider momentum. So we consider the same method to calculate the resultant, the angle that the resultant makes with the x-axis. Similarly, if you want with some other axis, so that way also you can calculate. Once your y component and x component are known to you, we can do any calculation, whatever is desired or whatever is required. So the concept here is, if we generalize the situation, concept here is calculate x component of any vector. Now I will not say only force, any vector, calculate y component of any vector and get the resultant. So x component square plus y component square root, that will be the resultant. Tan alpha, that will be y component, means sum of y component of all the vector divided by sum of x component of that particular vector. Simplified, you will get the magnitude of that resultant vector as well as the direction. So this is the general method for any number of vectors you can solve. So let us first use this method. So here 100 Newton at an angle of 60 degree. So it will have component along y direction, component along x direction. So this is 100. So if you calculate the component of this 100 along this direction, so it will be 100 cos 60 degree. And along y direction, it will be 100 sin 60 degree. Okay, because this angle is 60. Now along x-axis, if we calculate the resultant, okay, so along x-axis, component of these two forces along x, if it is suppose fx, then f of x, it will be how much? This is rightward force and this is leftward. This is acting towards negative of x-axis and this is acting towards positive of x-axis. So you can say 100 cos 60 minus 100. Because both are oppositely directed, so we are adding. In fact, we are adding, but we are adding with the proper sign. So positive x-axis, if you are taking with the positive sign, then the forces acting towards negative axis, it will be taken with the minus sign. So that's why I have written this with the plus sign and this with the minus sign. Similarly, fy, we have simply 100 sin 60 degree, because we don't have any other component of this force along y axis, because this is strictly along the x axis. So we have 0 component along y axis. So we can write this as 100 sin 60 degree. Because this is acting in the upward direction, so this force is taken with the positive sign. Now fx is known to us, fy is known to us. So the resultant force, that will be equal to how much? So cos 60, if you take, this will be equal to how much? 1 by 2. So 100 into 1 by 2, that becomes 50. So this becomes your 50 minus 100. So it means it is minus 50. It means resultant of this force and this force, it is finally acting along what? Negative of x-axis. Yeah, this is minus of 50. Resultant of this force as well as this force. So that is coming as minus 50. Y component, it is acting this side. So resultant will act in which direction? Resultant will be somewhere this side. That angle, let us say it is alpha. So 100 sin 60, that will be equal to how much? 100 into root 3 by 2. So 100 into root 3 by 2. So this is cancelled 50. So this equals 50 root 3. So fx is known, that is minus of 50. Fy is known, that is equal to 50 root 3. So the resultant, if it is f, then this will be equal to your minus of 50 whole square plus 50 root 3 whole square. You can simplify and you will get the value of this resultant force. As far as the angle is concerned, if this angle is alpha, then tan alpha, it will be, this line is parallel to this. So tan alpha, it will be this component divided by this component. This is 50 root 3, this is minus of 50, substitute, you will get how much? Minus of root 3, and accordingly you can calculate the value of this alpha. I hope this is clear. So that way we can calculate the value of this angle of the resultant that it makes with either the x-axis or with the negative of x-axis, and similarly you can calculate the magnitude of this. So let us see in this question. Now here in this question, a particle is having different displacement in different directions. A particle is displaced by 4 meter in the southwest direction, then by 5 meter east, and lastly 6 meter in a direction 60 degree north of east. We have to calculate the displacement of the particle. So here if you see the diagram, suppose the particle starts its movement from the point O. From this point O, is clear? So it moves from O to A. How much? 4 meter in the southwest direction. So this is your south and this is west. So when we say southwest direction, so it is equally inclined to south as well as west. It means this angle or this angle, it will be how much? 45 degrees. So this angle is 45 because this total is 90, and southwest means the equally inclined to south as well as to west. So this angle will be equally divided. So it is 4 meter and 45 degree, and this is 45 degrees. So 4 meter at an angle of 45 degree with the west line or with the negative of x-axis. Then it comes here and then travels 5 meter towards east. So with respect to this point, this side again it becomes east, this side west, this side north, and this side south. At every point you have to consider the direction, and accordingly you have to take the displacement. So this side it becomes your east, this is west, this is north, and this is south. So 5 meter east. Then 60 degree, 6 meter, 60 degree what? North of east. Now see here. So this particle has reached here. From this point again 6 meter. So again at this point you have your direction. This side again it is east. This side it is your south. This is north, and this side it becomes west. This is clear. So for this particular point, now see the direction. 60 degree north of east. So this side it is north and this side it is east. North of east means from east towards north at an angle of 60 degree. So from east towards north at an angle of 60 degree. So this is your angle 60 degree. From east towards north at an angle of 60 degree. So that is the displacement of the particle from this point. So 6 meter at an angle of 60 degree from east to north. That is north of east means from east to north. So that way we have this 60 degree and this displacement is 6 meter. Finally, we have to find the displacement of the particle. Displacement means what? The shortest distance between the initial and the final. This is the initial point and this is the final point. This distance we have to calculate, this shortest distance. This because instead of taking so many turns, the particle could have directly reached point C from O following this path. Okay, and this would have been the shortest distance, and the shortest distance we call it as the displacement. So we have to calculate this one. So here just to calculate this vector OC, displacement it is a vector quantity, so we have to calculate this OC from O towards C. So use the triangle addition law. OA plus this AB, can you say it is equal to OB? Okay, and again this OB plus this BC, that is equal to your OC. So that is our requirement. So we can write this as OA plus this AB plus this AB, it is equal to what? OA plus AB, that is equal to OB. So we have this as OB. Again OB plus this BC, that is equal to OC. So here we can write OB plus this BC, it is equal to OC. Now if you consider this replacement of this OB, it can be replaced from this equation. So it is OA plus AB. So OB can be replaced as OA plus this AB. And this BC here, so plus this BC, and that is finally your OC. Now let us see this equation. We have used the stepwise solution here. First we have considered the triangle addition law here for these two displacement OA and AB, and we got this OB. Then we have considered this triangle OB plus BC, that is equal to OC, justifying or satisfying all conditions or prerequisite of the triangle addition law. Now here, so finally we got this relation. Now we have to save our time. It is not that we have to just solve the problem. We have to solve it in an effective as well as the minimum possible time. So now if you observe this equation, there is no need of this equation as well as this equation. So once you understand things, directly we can do it. The final displacement in particular and the resultant of any vector in general, you can say it is nothing but the vector addition of all the vectors in between. In between, when I say in between, that is from the initial position to the final position. It is the vector addition of all the vectors. So vector addition, you can say it has started from this point and finally it has come to point C. So vector addition of all the vectors. So OA plus AB plus BC, that always gives you the final vector or the resultant vector, and that is here. If you talk of this question, then it is OC. So that was our requirement. So OC is what? Sum of all the vectors between this point O as well as C. So between the initial point as well as the final point. So whether you take these three turns, you take 4, you take 5, you move like this. You start from here, go like this, and finally you reach here. You have to find, this is suppose O and this is A, this is B, C, D, E, F, and this is G. So taking so many turns here, you finally reach this point G. You have to find the displacement. It means our requirement is this. We don't have to do all those steps. First vector addition for this, then vector addition for this, vector addition for this, and all that. Directly we will write OG is equal to OA plus AB plus BC plus CD plus DE plus EF and plus FG. This is OA. Sorry, OG. So OG is equal to sum of all the vectors in between. In between means from the initial as well as the final vector or the initial or final points. Now OA, if the this OA is the position vector of this, AB is the position vector of this. To calculate the value of this OA, AB, BC, CD, just resolute them along x-axis and y-axis. If it is 3-dimensional, then along z-axis. Use the unit vectors I and J. I along the x-axis, J along the y-axis, and K along the z-axis. So replace all these vectors with this I, J, K unit vectors after resolution. Once you get that I and J and K, just add them or subtract them with their proper sign. If they are with the plus sign, that will be added. If they are with the plus minus sign, they will be subtracted. And finally you will get the components I, J as well as K, means x component, y component, and z component. Once you get the components of this resultant vector, the magnitude will be what? X square plus y square square root, and the direction will be the tan alpha, direction tan of the angle that it makes with the x-axis, that will be y component divided by x component or unit vector j divided by unit vector I. Is this clear? I am talking of the 2-dimensional. If it is 3-dimensional, similar concept remains. Slightly there will be change in that, which we will see in the coming classes. So here OA plus AB plus BC, that is OC. Now let us calculate this OA, AB and BC. Put the values and we will calculate x and y component of this entire vector or the total vector, and from that we will get the resultant. So now see this. OA, it is at an angle of 45 degree with the negative of x-axis. So can you say, if it is 45, this component will be how much? 4 cos 45. This is this side. Okay, so you can directly write, you need not worry about this angle. If this is 45, then 180 minus 45, this is this angle, then again you convert it into obtuse. These are just the theoretical things. Once you have learned the thing, use the easy way to simplify the problem. Either you say it is 145, 180 minus 45, or I simply say, you will write this component, or some of the books they will suggest you write 4 cos x component of this 4. So x component of this 4, it will be 4 cos 180, how much? This is 180 plus this 45, because this line is at this angle. So 180 plus 45. So 180 plus 45. You are getting this as an obtuse angle. So obviously 4 cos 180 plus 45, that is cos 225, that will be what? Negative. So you will get x component, they will say, or some of the people or some of the books they will say, you write plus 4 cos 225 degree, and when you find the value of cos 225 degree, it will be negative. So that quantity gets converted into negative. So either this is the approach you can do, but unnecessarily you will be confusing yourself, because calculation of any trigonometrical function as far as the obtuse angles are concerned, we always get confused. So just to avoid those confusion, why should I go for this 180 plus 45, then I will get the minus sign, and then I will say that it is towards the negative x-axis, not the positive x-axis. Directly I can observe when 4 meter is this side, when I am moving this side, and this is my west means the negative of x-axis, south means the negative of y-axis. So already when I am in the negative side, how can my component will be in the positive side? So what is the use of getting so much of contradictory statement? So just it's my 45 degree, I know it is towards negative x, 4 cos 45, so obviously it will be towards the negative x, so it means it will be with the minus sign. So that way you can simplify and you can proceed further. So here if you see, so this will be 4 cos 45 this side. Another component here, y component, it will be 4 sin 45 this side. Next it is 5 meter towards east. East means towards the positive x-axis, so it is already positive. So 5 meter along this is 6 meter. So again we are moving up in this direction. So one component will be this side, another this side. This is towards the positive x-axis and this is towards the positive y-axis. So this and this angle is 60 degrees. So this will be 6 cos 60 degree and this will be 6 sin 60 degree. Both are along the positive x and positive y, so obviously both will be with the positive sign. Now it means my displacement will be what? OC, and our OC is equal to how much? Your vector OC, it is equal to OA, and OA is 4 cos 45 towards the negative x-axis. So should I take minus of 4 cos 45 I? Unit vector I am using I for the x-axis, minus sign because it is towards the negative x-axis. Another component was 4 sin 45 towards south, means towards the negative of y. So minus of 4 sin 45 j along y-axis. 5 meter east towards positive x-axis, so plus 5i. Okay. Next it is 6 meter. This component was how much? 6 cos 60 towards positive x-axis, so plus 6 cos 60i. 6 sin 60j along this direction, so plus 6 sin 60j. So we have taken all that, that is OA, this is your OA, plus AB, this is AB, plus BC, so this is your BC. Now you have I component as well as J component, means the X component as well as Y component. So add or subtract I with I together, J with this J. So once you get this, so let us say after calculation that you can do, after calculation we get this OC is equal to xi plus yj. Means x equals what? Minus 4 cos 45 plus 5 plus 6 cos 45. If you calculate, I am assuming that value as x. Minus 4 sin 45 plus 6 sin 60. Once we simplify, I am taking that as y. So finally we got, let us say, OC is equal to xi plus yj. So what will be the magnitude of this displacement? OC is equal to your x square plus y square square root. And if this OC here or here, that is the same extended line. If this OC makes angle alpha with the, this is 4 meter at an angle of 45 degrees. This line or the inclination of this line is different from this, and inclination of this we don't know. So let us say it is alpha. So can you write this tan alpha is equal to this y component and divided by x component. So solve this, substitute the value, you are getting the magnitude of the displacement as well as the angle that the displacement makes with the x-axis. So that is the final displacement of the particle. I hope this is clear. So whatever calculation or discussions we have done, if you try to summarize, the only thing is, if you have to calculate the resultant of a vector, either it is in terms of that vector is in terms of any vector, force, displacement, momentum, anything that you can say, just consider the position vector of that, starting from the initial point to the final point, or starting from the first force to the last force. This is the position vector of all those forces, all the displacement, any other vector quantity. If it is 2-dimensional, then in terms of I and j. If it is 3-dimensional, then in terms of I, j as well as k. Once you have calculated this with the proper sign, and how you get the proper sign, that we have already discussed. Simplify and calculate the I component of all the vector, j component of all the vector. I component, that is your x, j component, that is y. Once you get this magnitude, you can calculate like this, and direction you will get like this. I hope this is clear. So we will discuss more and more questions based on vectors in the coming classes. Thank you.